Hi guys, in this video we're going to implement the HUD, which is the 2 lines of text at the very top of the screen there, and you can see that the time is ticking away now. All of this starts now. So we're going to create an empty one called HUD and put that at 0, 0, 0, and then we need to have our score and our lives, right, empty lives. And then the car that we're on. Create empty car. So just to let you guys know that this is the screen that I'm basing this on here, which is our Automania screen. So we've got our score up here, the time here, lives, car, and then we're going to have the lives indicator there. So that's what we're working on just now. And it's just picking place stuff basically. So I'm gonna import the font. I've already created the font, which is this one over here, and pixel brain is gonna be 1, and it is gonna be point no filter clamp. Yep, and we'll click on apply, and then open the sprite editor, and slice is going to be top left, and we're going to be doing it by cell count. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 columns, and we've got 5. 1, 2, 3, 4, 5 rows. 5 rows. Delete existing slice. There we go. So we've got these ones here. So it's going to make it easier for the score as well. So you get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. So we'll apply that and hit return there. And then for our score, we'll just add our first sprite, which is going to be our font. So we're going to scroll down to score. Let's make this a bit bigger. So we'll drag that into there. And of course, the score is going to be the pixel perfect one, which is pixel perfect. There we go. So we'll do a copy of this. CORE, and so this one is going to be at position 8. It's too big, isn't it? Or are these too big? Oh, these are too big. Uh-oh. Alright, let's fix that. So I brought it in, and obviously it's 16 by 16, and they're clearly not 16 by 16, so I'll go back into our sprite editor and resize. I'll remove. So I wasn't going to do all of them. Okay. And then we'll slice them up, and then it's going to be 12 by 5, which is right. Slice. There we go. And top left, and apply. And now we're back to the start there. So that is going to go to 8. So we're back to normal there. 16. 24. And of course the last one will be 32. So for this one, all we need to do is just choose the right font. So that would be C. O, and then this one will be R, and this one will be E. And of course I'm going to do this for the rest of these. We don't have to watch this. I will continue with this, and then I'll come up with the full HUD, and we'll see you in a bit. So you can see that most of the upper part here, the one here for time, I don't think we have that, but I have a cunning plan which may or may not work out, but let's see. So there is a block here, which is not this one. It's one of these blocks. There we go. 1, 2, 3, 4. I think that's 4. I think that's 4. So that's 22. Is that right? Let's find out. It is. If we go into the sprite editor here, actually, it'll be able to tell me. So this one here is 22. So it is that one, 22. Okay, so if we grab 22, which is that one again, and then for our time, let's add another one here, and then this one we'll create an empty one. Actually, do we need to? No, I don't need to. Let's just grab that to there, and then that's going to be at -8. Oh, but it's already at -8, so it's going to be 0. Sorry. But we need to bring it down 2, so it's -2 to make it in the middle. And we also need to move it 1, 2, 3, 4, 5 along, so that's going to be 40 along there. And then the draw mode is going to be, I think, sliced. Sprite used is not generated with full rect. Maybe not then. Simple. Maybe not. Okay, so I probably can't scale it on the X. Oh no, I can scale it on the X, because that's where the pivot point is. That's perfect. Okay, so I think we've got here 10, 11. Okay, so if we make that 10, that means it's 10 characters. So it's 10 times in size, because it's going to be 10 characters long. I think that's how far it is. That would make kind of sense. And then all we need to do is, because it's 10, it's just a matter of scale. So when we bring it down, we can just bring it down like that, and you can see that the time is running out. Obviously we can't go to negative time, but yeah. Okay. So the next thing is we're going to have to create some classes that help us turn things off and on, and let's do that just now then. Right, let me go ahead and create a script, and we'll call this environment housekeeping, and we'll call this one HUD controller. HUD controller. And then we'll create another one called lives HUD controller. Okay. And create another one called score controller. Do we need? Yeah, I think we do. Controller. And I should actually call that score HUD controller, because that would be consistent, wouldn't it? Okay, HUD controller, and then we'll create another one again called time HUD controller. And then car HUD controller as well. Which we need to actually create an indicator for, but we'll do that later on when we get to car HUD controller. Car HUD controller. Okay, so lives is going to be our lives HUD controller, so we're going to drag that on there. And then we'll fire up Visual Studio. So we're gonna have public object, game object, Wally's. Let's make that actually private serialize field, because we don't want to expose it to there, but we do want to have public int lives get set, and get is going to be return Wally's dot where Wally dot active in hierarchy count. So we're going to return however many Wallys are going to be there, and then the lives, the set, we're going to say for int I equals 0, I less than Wally's length. If well, let's say var lives equals, and then we'll clamp it. So we'll do math clamp, and then we'll specify our value. So the value is going to be value, and then the minimum is going to be 0, and then the max is going to be Wally's length. Okay. And then we're going to say if I is less than lives, actually it's just going to be Wally's I set active I less than lives. So that is going to, so that property there is just going to be our accessor into displaying the correct number of Wallys. So anytime we want to set the number of lives, we just decrease the number of lives using that controller. We can also create an editor as well, so we can create our editors here. So we can do create a folder editor, and we'll call this lives HUD controller editor. And then this is going to be our editor. Unity editor, and then this is going to be our custom editor type of that. All right. Draw. Is it green inspector GUI? Oh, inspector GUI, that's the one. And then we can also set the number of lives in there. So we can say var lives equals, oh, yeah, we need to get an access to it. Var target lives controller equals target. So we can say var lives equals lives controller dot lives. Editor in horizontal. GUI layout and horizontal. Label debug. And new lives equals editor GUI. Int field, and then the value is going to be lives. if new lives is not equal to lives, lives controller dot lives equals new lives. Yes, for funsies. Okay. So now we go to our wallies. Wallies there. And we have our list of wallies there. And I'm going to grab that one there. Grab that. No, grab that one on there. And then drag that into there. Like that. And then the number of lives is equal to 5 currently. Is that going to be a problem? I'm just wondering. So if it's active in the hierarchy, then it's going to be 5. Okay. Alright. No, that's fine. So that's going to give us the number of lives because they are active in the hierarchy. So if I run this, so we got our lives there. If I set that to 4, there we go. 3, 2, 1, 0. There we go. So again, I can set that to 5 as well, and that brings back all the lives. So that's dead easy. So that's our lives HUD. So the next thing we need to do is we need to do the same thing for score. I need to fix up the car one, and we also need to do one for time as well. So I will crack on with that and meet you back here. The score one is going to be very similar. It's going to be you give it the score, and then I'll go through it rather than watch me type it. That was just me doing a sort of example of how it's going to look, and they're going to look very similar to this here. So rather than boring you with that, again, I don't want to keep treading stuff because it can be quite boring watching me do these things. I don't think there's going to be any trippy uppy things. If there are, I'll stop what I'm doing and I'll record the video. But in the meantime, let me catch up with a bit of coding and I'll crack on. Well, it did go wrong. So if I type in 1, 2, 3, 4 here and then click on update, it should display 1, 2, 3, 4 up there. However, it's not working. So the way I thought I'd do this was, let me interrupt to just explain this just a little bit briefly with some diagrams about what I mean. So what I want to do is I want to get every digit of the score and use the individual elements of each of those digits of that number to index into the sprites so that I can display it on screen. So what I'm going to do is I'm going to use the base conversion algorithm, which I do a great job of butchering it in here. But essentially what the story is, you take your number in base 10 and you mod it with the new base. So this is the number 1234, which just so happens to spell it 1, 2, 3, 4. You mod it, and then that gives you 4 because that's the remainder, because 1, 2, 3, 4 mod 10 gives you 4. It's the remainder part of it. And then you divide the number, and then because it's an integer division, we drop off the 4, and that effectively gives you 1, 2, 3, and you keep repeating that. So you can see that we get this one here. So the first number was 4, second number is 3, 2, 1, and then eventually you're left with no more numbers to proceed to process, and so that's it. You just fill it in that way. Now, here's the actual algorithm. So this is the code that I'm writing just now. So you see that the number that we get in here is going to be our score, 1, 2, 3, 4. Our base is 10, which I haven't fixed for some reason, in case I wanted to make it base 16. Who knows? So while the number is greater than 0, you take the remainder of that, you figure that out using the mod, and then you do something with the remainder, which we'll get to in just a second, and then we divide that number by the base. So how do we implement this? So in our score, you see at the top of the score there, we have our 6 digits. So the least significant digit is the rightmost one. And so that's our starting point. So this part here is our starting point. So that's which just so happens to be the length -1. So these are index 0, 1, 2, 3, 4, 5. So it's this one here, which is 6 minus 1, which is our 5th element. Not to be confused with the movie of the same name. And then we have an array that holds the digits 0 to 9, which comes from our bitmap font, which is also a sprite sheet. So what we do is if we wanted to convert this number here, 1, 2, 3, 4, our current index is 5, so we're pointing at this one here. And you'll see that we now put that in that position. We then divide it by 3 and decrement the index. So that brings us to index 4, which is our next one. So we put 3 in there. We then divide the number by 10, and then that puts us in this position here. And then we move on to the next one, which is 4, which is the index 2, and that gives us 1, 2, 3, 4. So anyway, that's kind of what I was trying to explain in all of this. Back to the video. I would clear out all the indicators and reset them to digit 0. So every score gets reset to 0 when the score changes. And I mean, it happens in this frame, so it's not going to be like a flicker or anything. And then take the score here, put it in temporary here, and then basically mod the values of the unit, which is 10 in this case, and then while we still have values in temporary variable, keep going to the left, and then modding the next available value, so it'd be like 10, 100, 1000, and so on. So digit is 4, which is right, so the sprite of I, which is 5, which is right, is equivalent to whatever digit it is there. But of course it's not right, because it should be digit -1, because 0, 1, 2, 3, 0, 1, 2, 3, 4 would be the 5th digit, actually. Because 0 is the 0th digit. 1, 2, 3, 4. Yeah, so it's going to be the 5th digit. So that's wrong to start with. Although 0, 1, 2, 3, 4. I mean, that does actually make sense. So sprite should be the right one there. Anyway, irrespective of that, so we do that, and then we get our unit. So our digit is going to be 30 in this case. It's not really, oh, that's what's causing the problem, is 30. So we need to divide it by 10. So whatever the previous one is. Okay. So we need to get it into the tens column. That's what's causing the problem. Okay. Is there going to be an easy way to do that? I don't think. Not without introducing another couple of things. Okay. What I think we should do is we need to divide it by 10, and then that gets us the right value. Because I think the problem is, yeah, I'm not doing the right thing there. Oh dear. So we don't want to multiply it by 10. We actually want to say remove that and then do temp is divided equal to by 10. So really it's just always going to be 10. So we don't need that variable there. And then the rest of the digits are all working. They all make sense. So let's run this. So we'll run it again, and we'll type in 1, 2, 3, 4, and there we go. We get 1, 2, 3, 4, and similarly, if we do 10,560, we should get 10,560, which is what we do get. So that's working there. So we've got our lives working. We have our, it says lives debug. There you go. Let's copy pasta for you. So if we go to here, instead of lives debug, we can do score debug. So now we got that there, and we just need to get the time working, which I think should be fairly straightforward, to be honest. Yeah, okay. Let's get that working now. So what I've just discovered, of course, is in the course of doing this, is car and score are very similar to each other, and in fact, it should just be counter, because if we run our car here, if we run the game and then we select our car indicator, and you see that lives are currently set to, the value set to 1. If I set that to 5 and click on update, it just works. So I'm going to change the name of this to counter instead of score, and that'll make it a little bit more generic in its naming. So if we go to car, we can set that to car number 5, and if we go to score, we can set that to 10,570. And there it sets that. And that's everything now set to counter, so just a wee kind of generic thing. And that'll work with however many digits that you have there as well, so it's fairly reusable as well. And now time. Let's do time. And we've got that one working now, so when we move the slider there, you can see that it moves the bar, which is perfect. So the only thing now to do is to get everything in one place, and then create the prefab from it, and then add the color. So just a very, very basic class, the HUD controller class, and go back into here, and then we just add our HUD controller there, and then we can we've got our time indicator, so that goes in there. We have our car, so that goes in there. Score here, and then lives is further in here, so that is the number of Wallies, I think it is. So there we go, there's Wallies there. And that gives us our prefab. Well, it doesn't give us our prefab just yet. We go to prefab, and then we'll create a new folder in here, and we'll call this UI elements, and I'm going to drag HUD into there, and that gives us our HUD. And then in our game controller, I'm going to add the HUD controller to that as well. So serialized field, HUD controller. Okay. And now that we've got our HUD controller in there, we just drag and drop that into there. Why is HUD controller not there? Oh, because I never... Wait. Did I not add... Oh, was it the game running? Oh, well, that's not good. So it was on time. So if I do copy component, and then let me do this inside here. So I'm going to go to time, and then we do copy component, and then we go to HUD, and we can do paste component as new, so it pastes everything in there, and then we go back to time, and then we remove that there. So remove component. Okay. So now we go to HUD, and we have those objects there, or those references there, and then we can just drag and drop that into there. So now our game controller has access to the HUD. So our time, for example, that's going to be a variable that's going to decrement there, and Same thing with the score as well. It's going to have easy access to the score. So anytime we update the score, we can update the visual of the score there. And the same thing with, you know, what car number we're working on, the number of lives we've got, all that kind of stuff. We'll add that in just a sec. But first of all, I think what we need to do is we need to add a little bit of color to the proceedings. So right now, it's very bland. The top there, the HUD, it's not colorful. So we're going to add the color to that, and I'm going to do that the same way that we do the other ones, and we'll manipulate our attribute file. Yeah, I think that's about all we need to do there. And then we'll add our HUD. We'll add the time decreasing. Bit of Sean Connery creeping in there. And then that'll be us for this video. I'm going to attempt to... So that the attribute setting is this weird upside down version of it, which is this index here. Our attribute is and part of an 8x8 block, as you know. So this is our screen here. So we have our screen here, but as far as the ink is concerned, we was going back to, oh, good grief, I can't remember what video we did this in, but it's one of the earlier ones where we've used a texture for the ink and for the paper color, and then we pass that into our shader. So the ink color for this is the ink color for this is a texture that gets sent to the shader, and that actually looks like this color here. So to get to the 0th element of the array, that's the top left hand corner. And remember, this is just a flat array, so this is actually an array stored from 0 to 767, which gives us 768 cells for this. So it just so happens that this is the top of the array as far as we are looking at it. However, and it makes it a lot easier to figure out as well the index into the array. So this one over here is 0, and this one down here is the 31st column, 23rd row, which is 23 times 32 plus 31 gives us 768 for this one here. So that makes it a lot easier for us to do this. However, this is not how the shader sees it. The shader actually sees this texture flipped horizontally. There's reasons for that. I didn't take this into consideration. I should have actually flipped it in the shader, and maybe that's what I should have done, but I decided to fix it here. So we ended up having a bad coordinate system, but luckily it's easily flipped because the math is quite simple. So this is the screen as we see it. So this is how we see it in the game. You can recognize it just from the colors, where you've got the parts are in cyan, the doors here, Wally's here. These are the ladders. It kind of looks like the game, but when we actually see it in the texture, it looks like this. So it's actually flipped horizontally, not vertically, but it's flipped across the x-axis. So what's the formula for this? Well, the formula for this is a little bit more complicated, and it's down the bottom there. So the index is 23 minus y times columns plus x, and that's the only difference. So to get to this one here, which was our last one in the previous one, the previous formula where it was the normal way around, that would be 768, but this one here is actually index 31, which is basically the 0 starts here and then goes along in the x direction. And so that's what I'm coding up in this bit here. So back to the show. And it's not quite right. So I'm going to attempt to fix this, or at least do it right for the top part of the screen, and then we can probably rewrite it later on, which means we probably won't end up rewriting it later on. But this one here, this goes to get the index, which is the object start position plus y multiplied by the screen count plus X. But I think that's not right. So if I go to, where's our paper here? Our paper gets set to this update. So start, describe room. So in our excuse me, in our describe room we've got our static ink colors. So if I set the first one to be red, I don't think it's the top one. So if I do static ink colors 0 equals palette, and then it's going to be red, which is our second color. Yeah. So if this is red, if this one up here is red, then that's not exactly where I thought it was going to go. Okay, good. It's not red. So what I think is it's this one down here. So if I go and grab this here, and then at the very end of this, I set the bottom one to be, sorry, the very first one to be red. Yeah, it's this one down here, which is exactly where I thought it was going to be, because it starts off at this point here, because it's flipped. So imagine if it's upside, if the screen's been flipped horizontally, that's essentially what we've got there, which means that our X runs to the right as expected, but the Y runs down the screen. Okay, which means that if we want to draw something at the top of the screen, so if we want this S to be red, that means that we have to flip whatever this value is here. So it's going to be 24 minus 0. Yeah, I'm making sense to myself. Okay. So if I do 1, then that'll be the next red one. Yeah. Is this making sense? It's making sense to me. I'm just not explaining it very well. I should probably put a diagram up on the screen now, just to explain to what's happening. So you can see that the attributes are actually inverted. So although we've got the blues and the yellows and the greens and all that kind of stuff, you'll see that it's actually drawn flipped vertically on, flipped horizontally on the x-axis. So it's upside down essentially. So I'm going to write a little routine that solves that. And let me get rid of that. So we want to plot on these colors here. So these are color, these ones here. Okay, so I want to say rivet plot color colors and X and Y color. Okay, so our X is going to be the same no matter what it is. Int Y equals 24. Is it going to be 24 minus? No, it's going to be 23 because we want to flip it. 23 minus Y. So whatever Y is, it's going to be that. And then our actual position is going to be index equals Y times that plus X. And then we say colors index equals color. So now if we go to here, we can then do plot static ink colors and then 0, 0 palette 2. So that should paint the S in start red. Sorry, S in start. The S in score red. So let's give that a run. Didn't like that. Oh yeah, why? Okay. And that can be var, and that can also be var. Right. And oh, didn't like that. So didn't like it at 218. So 218 will obviously be this one here. So that's going to be 23 of those. That doesn't seem right. Let me attach that to there. So we got, well, actually, you know what? I'm saying player screen column count, but we've also got player screen row count, which is 22. But it is. That doesn't make any sense. So index is 736. Colors is 704. Hold on. 32 times 24 is 768. Aha. So that is wrong. So where am I computing that? That is play screen column count, screen row count. Let me just what have I got there? I've got 22 times 32, which would be 704. 23 times 32, 736. So that's going to be +2. And this one here, +2. Alright, so now that we've got that, the correct size of buffer, so we go back to here, you'll see that we've got our the row count, which is 22, because that's the actual size of the play area, but we also have +2 for the top of the screen as well. So now, fingers crossed, this should all work. Well, it didn't crash, and that's kind of good. But I'm wondering if I've got the wrong size of texture now. Here's the problem. Here is the update. So it's not the fact it's the description part of it, the describing the room part is this part here. So what I'm going to do is I'm going to permanently, so this is play screen row count. I'm also going to have full screen row count. Don't know why I copied that, but never mind. 24. And that's going to get used inside the update, which is this one here, this one here, this one here, this one here. and that's going to do that there because it's going to be 24 times 32, which gives us 768. And then in the describe room, just to keep our lies consistent, I'm going to put that in there and put that in there. And now, after all that, drum roll please. Hold on. We should get a red pixel, a red S. Ta-da! And nothing else, which is perfect because that's what we're going to set that up. So next thing we're going to do is do a run. So instead of having just one pixel, I'm going to set it to be whatever number of pixels we want. So int run size equals 1. And then we're going to do for int x equals x less than x plus run size x plus plus. That there and x. So that is going to add our let's just check that. So x is going to be whatever x is, and then it's going to be x is less than, oh sorry, that's going to be x is less than x run size, add 1 to x, and then we add that to there. So now we have our magenta. So where's our plot? I've lost the plot. So palette is going to be 3 because that's what magenta is. Should probably have names for these actually. And then the run is going to be score plus the equals, which is going to be 6, and that is going to be for score. And then our time is going to be at 1, and that is going to be 2 because that's red, and this is going to be 5. So now I'm wondering if we have to use -1. No, it doesn't make any sense, does it? No, it doesn't, because we're subtracting already. Yeah, okay, so there you go. So you get score equals that. Oh, I've still got that near top. Where's that near top come from? Here we go. Let's comment that out because that's annoying. So then we have our where are we? We're at the time. This thing here is going to be yellow. So inside our level builder, we're going to have it's still on the second row, but it is 5 in. So it's 5 in, and that's going to be time progress bar, and the run for that is 10. This is so much easier now that we've got this. We can paint our attributes on here. Oh, wrong color. It is not that, it is yellow, which is 6. We also need to do the score as well. So our score indicator is 6, 0, 1, 6. So we start at 6 and we go for 6. So that's our score indicator. And then the time progress bar, and then we need our lives. and that is going to be green, which is 4. I'm remembering this off the top of my head. I don't know why. So 0 is black, 1 is blue, 2 is red, 3 is magenta, 4 is green, 5 is cyan, yellow is 6, and white is 7. Don't know why I remember that. It is just burnt into my head. But that's the palette colors for the ZX Spectrum. And then for this one here, we're going to go 16 along, and it is green. Yeah, that's right. And then the car indicator is 1 down from that, and it is 7, and it is 1, 2, 3, 4, 5. 5 is a run of 5. And that's going to be car indicator. And then the lives indicator. Indicator top row is going to be 16, 17, 18, 19, 20, 22, 22. And it's going to be palette of 7. And it's going to be a run of 10. And then the bottom row of that is going to be 1 down from that. And that, I think, fills in all the colours on the top part of our indicator. There we go. Perfect. Looks great. And the only thing we need to do now, I keep saying the only thing, there's a ton of things we need to do. So that's our score there. It's starting to look a lot like Automania, just from this. I'm actually quite chuffed at how, like, even the color clash and everything. It looks like a ZX Spectrum screen. So we have our lives, we have the car, we got the score, all that kind of stuff. We need the time to go down, and I think that'll do us for this video, but let's do that just now. So our game controller, let's give you 2 minutes on the clock. So that means we've got private float clock equals 120. So there's 120 seconds on the clock. So you get 2 minutes to do this. That's probably too little, isn't it? We'll see how it goes. So clock is that, and then for our update, so it's normal gameplay. We're going to do clock minus equals time dot delta time, and then our HUD time current equals clock divided by 120F. There you go. And obviously we'll tidy this up and you pause it and all that kind of stuff. And actually I don't think there's a pause in this game. I think you just got to sit in the corner and let time run out. There we go. And you can see over here that the time is indeed running out. I think 2 minutes is a bit stingy myself, but we can play with that. In fact, I'll check the game and see how long you actually get for there. But I think that does it for us just now. Thank you very much for watching this. I appreciate there's other videos that you could watch out there. But if you liked what you see, then don't forget to hit like and share, if you wouldn't mind, on the because it does help the channel out. And if you want timely reminders of when I put something new up, then hit the subscribe button and notification bell, and YouTube will let you know when I put something new up. But I hope you've been enjoying this series of videos on Automania for the ZX Spectrum. I certainly have. I've been having a blast with this one. But yeah, I will catch you guys in the next video. Until then, thank you again. Bye.